In this interim report, we will be going over the design of a ball pump. The team members include Lindsay Tyrell, Elisa Daydono, Madison Wright, and Elise Collins. A ball pump takes air from the external environment when the piston is moved upward and then releases it through a small hole in the top of the pin when the piston is moved down. This therefore transfers air from the outside into a wanted object.
This next slide shows the exploded cab view, which allows us to see the inner workings of the ball pump and how each individual part of the assembly fits with the rest. Going from the top down, starting with number 1 is the grip, top cap, rod, gasket, plunger, stopper, cage, shell, bottom cap, and finally part 10 is the fill pin. Next, we're going to take a look at the market analysis. So the primary customer is the equipment managers of athletic organizations who use the pump to inflate balls and consistently maintain a high pressure that complies with organization and league rules. The secondary customer is going to be families who would use the ball pump to replenish pressure of balls for personal use. Now, they won't really use the pump as much as a primary customer because they only use it to restore a ball to a pressure that allows play. This pump would also need to be both child-friendly and safe. Now, just for a little more background data on ball pumps, there are approximately 14 primary manufacturers of ball pumps in the U.S., and roughly 1 million are produced annually.
Next up, we have the fast diagram for the ball pump. Its main objective is to inflate objects, and it does so by entering a valve of the object is trying to inflate and transfer air into it. To enter the valve, the entrance of the ball pump must be small enough to prevent leaking, and it also must be able to be precise to align to the escape. The ball pump can take the outside air and compress it, contain it, and eventually extrude it into the object. The ball pump can also release pressure in order to keep people safe, because if an object is way too inflated, it becomes a hazard if it pops. And finally, a comfortable grip can be a lot more convenient for users to use since they can have a good grasp on it before using the object. Next up, we have 2 different assemblies for the ball pump. The first one starts with more of a top-down assembly, starting with the grip and working its way down, while assembly 2 focuses on starting towards the bottom and building its way up. It focuses on having a larger sub-assembly which contains all the inner workings with the rod that can be later added to the main assembly. The sequence comparison highlights how the second assembly is a little bit better, just because since it has a larger sub-assembly, it can easily be added on, and since it starts from the bottom to the top, it is easier for the manufacturer to hold while it is being assembled. Finally, we have the function component mapping matrix, which highlights how each of the objects in the assembly complete a certain task function. A lot of the internal objects, such as 4, 5, 6, and 7, contribute with completing the task function of transferring the air, since it can compress the air and extrude it out of the pump.
Next, we will be moving on to the bill of materials. The analysis for the bill of materials was completed assuming that 1 million units would be made. That number was determined based off of a market analysis that was done prior and the projected volume that we would want to reach within a year. The most expensive part within this analysis was the plunger, and that's partially due to the manufacturing process. It has relatively tight tolerances in comparison to other parts, requiring more precision with manufacturing. Our least expensive part would be the rod, as it exists as stock and would only have to be cut to size. And then moving on to what the quad chart classification would look like for our 10 parts. Our parts with the lowest functional importance and lowest manufacturing costs were the shell, top cap, and cage, as they do not serve the primary function of inflating objects directly. And then our components with the highest functional importance and highest cost were the plunger and fill pin, because they directly influence the inflation of objects.
Next, we have the function differentiation table, which highlights how some functions are constant for both designs or customer groups, while others can be varied while still maintaining the general functionality of a ball pump. For example, the secondary customer group will have a design that varies from the primary group in terms of the grip and means of preventing leakage. Somewhat similarly, the component commonality table highlights the specific parts that are varied to create a new ball pump design for the secondary customer. Specifically, it shows how the grip and fill pin are differentiating modules, also known simply as modules.
For the product differentiation between the primary and secondary customers, the common interfaces include every part of the ball pump besides the grip, the bottom cap, and the fill pin. As a reminder, our primary customers are sports equipment managers, and our secondary customers are children and families. For the redesign of the grip, we decided to make it easier for a smaller hand to actually fit around, and therefore making it easier for a child to actually use. And for the fill pin, we decided to redesign it to make it a snap fit in order for families to take off the pin when they're storing it, and therefore making it safer for families to have around the house. This is the product family assembly design table, and as you can see, you can basically delay the differentiation between the two designs all the way until the end, and the only differences are between the grip, the bottom cap, and the fill pin.